G'day everybody. Thanks very much for the opportunity to come over to NZ from Australia to carry on about the meat burgers. Our meat industry is also quite eagerly watching what's going on there as well, especially as a lamb producer. So why aren't we using drones? I've retitled my talk today to basically have a think about it. Now, everyone knows what that is, an icebreaker. All good presentations start with an icebreaker. This thing on? Tough crowd. What do the two goldfish talk about in the tank? How do you drive this thing? God, hard. So, there are a few familiar faces out there that I noticed when I arrived, which put the fear into me of snoozers. It's mid-afternoon, a few talkers, could happen. So I decided I'd adapt. I saw this app come out, hopefully you're downloading it now, and going to try and have a go with using the polls on there. PowerPoint gets a little bit boring, doesn't it? Let's all face it. And a little bit of background about myself I thought I might include in the precision ag space, and drone on a little bit about my own adventure with the PA stuff. And I've also borrowed a little bit of the next speaker's time as he offered it to me. So, none of this please. The joys of mates and Snapchats. So, poll time. We might kick off with that on the app. So, I think we open that up. They come live on the screen. So, just a few background questions. So, do you ever use a drone? Time's clicking. So, the idea about this is, right now I've been in the UAV game since 2011, so it's at 8 years of it now. We've got guys doing it flying full-time commercially, which is a rarity. Drone companies seem to come and go more than your underpant colour, and we're kind of at the point now where, I don't know, we've heard so much about it, but it hasn't really taken off, has it? So I want to just kind of sound out the room here, see how the hort sector goes with it. My experiences have been in poppies, wheat, potatoes, peas. There you go. So bugger all the room is using a drone. Some of the challenges with it is exactly this. Like, everyone's seen drones, heard drones, but nobody's really applying them or using them. So if we go to the next question, what do you use it for? So scouting, by that I mean, are you going out actively looking for problems, taking photos, going and having a chase of it? A lot of people just put them up, take pictures. That we've heard a fair bit about the social media stuff. My own site, if you want to have a look on Instagram, is Thorpe_farm. I put a lot of imagery up there taken with the UAVs. It's a great way to communicate and show things. Like, so much of what we do is visual, and yeah, picture says 1,000 words. Asset and livestock inspection, so by that I mean looking at fences, going and checking water troughs, having a look at something that's up high. A lot of guys check gutters on buildings. There you go, pictures and videos. Not many people are doing that. Precision ag data collection, a few of you are doing it, and scouting. So the thing you see in the marketing, you know, all this precision ag and it's going to revolutionise farming, it's not coming to the front, is it? Next one will come up. It's interesting, this one, have you engaged UAV business? So I'm wearing a UAV company shirt underneath here. That's what I mean, that we're finding a lot of these UAV companies come and go, and I use the saying with this, most of them have come along to make money off you, not with you. And because they haven't come along in the journey and invested in what you're doing, I'm finding that the uptake of using UAV businesses has really been stymied by this. So a lot of people have come in and gotten burnt and haven't come back to it, or just won't engage full stop because they don't quite trust it. I'm guessing it'll be a resounding no. Look at that. So that's what life's like owning a UAV business. It's a tough space in agriculture in particular to try and get traction. So there's only like 3 people that have tried it. I wonder if they got a return out of it. So, return on investment. That's kind of where my forte is in this space. So I've turned around and I'm a man of many hats. If you read the bio, I've done a fair bit of stuff. And joining the dots together, I think that's the critical thing that we've got to try and do in this space. And that's kind of where I've found the strength in our company's been, and why I've been able to persevere for 9 years. So we operate globally, all around the world, doing everything from unexploded bombs, landmine detection, iron ore deposits, new ore deposits, through to ag work, drainage, frost mapping, the whole lot. So obviously those of you who have engaged it, they do feel there's a return on it, which is great. yet you still get a group of people there that, can't see a benefit in it. And I think that's that problem, that we're not joining up the dots. We're thinking about drones as this silver bullet, when all ours are tractor. Ultimately, you can have a different colour cab. It can be green, it can be blue, whatever. You can change the rim colour, so it could be white rims, red rims, yellow rims, and you can argue till the cows come home about it, about what's best and what's bad. So drones are exactly the same. It's what you hook up to the back that makes you the money. And I think the first speaker talking about hyperspectral stuff, that has me pumped, because that is what we're missing in the entire space, is hyperspectral imaging that we can put on a UAV, the tractor, and quickly go and grab that data. So it's kind of chicken before the egg case scenario with the UAV game. So out of those, this one here is basically, I think point E is pretty common. I did a whole statewide survey of poppies. It was something like 128 growers, and I think 14 people logged in to the data. It was taken from bare paddock right the way through to finished crop, and you end up with a lot of agri-porn being produced by this game. You create a pretty picture of all your wins, some photos of your successes, and you see what happened. So it's intriguing kind of to see what's going on. Look, a lot of people are coming back. It's great. So we've got a small percentage of people using it, loving it and sticking with it, and everyone else, never actually used the data. A couple of people there doing that, and the rest of the group are not really feeling a return in it. I think that's pretty typical of what's going on in this whole space. So that's the poll time done. I was trying to preempt the results, pretty much showed us everything we wanted to say there. I won't dwell on this slide too long, but ultimately most people are battling to see a value proposition in their business. You've got enough stuff going on elsewhere, so much other low-hanging fruit. Bringing this UAV precision ag workflow into your system just is too complicated, don't want to touch it, too much work, and really I could spend my money somewhere else and feel like you get a quicker return on investment. But I'm hoping I can use my own site as a example of, no, you can actually get a pretty good return on investment, but you've got to join some dots together that aren't really that cohesive, looking at it from the outside. So down in Tassie, we're having a very dry year, so we've got a once-in-a-generation chance to take water out to the back of my farm. We're about, 2,500 hectares, and we have a high-intensity operation going on. On the left-hand side of the screen, your left, is where the house is, and the right-hand side of the screen, the square. So this is our main intensive block, and then the square, which is down the back, that circle, that was a whole big basin, 120 metres above the rest of the farm, and basically no power lines, no trees, and the fences were crap. So it was an opportunity to come in and have a go at it. We tried some dry land cropping. A lot of problems in the site. It was a swamp. The old man wasn't really keen on us trying to push pivots into it and try irrigating. It just, to him, on his experiences, it wasn't going to work. But I could see it from a UAV and a precision ag space that there was potentials to do it. So the idea was to basically do foundation data collection before I even invested into the system. So what happens in Tassie is the government is bankrolling the scheme. We buy in at about $1,200 a megalitre for the water, and then you do a water access management plan, and you go out and they'll build these schemes. So before you even go and roll the dice on buying, 750 megs of water, it's $1 million worth of water just to start, and then do the investment. How big can I go? How much water do I buy? Is it going to work? What sort of scenarios are going through your head? So this is this greenfield site and the foundation, what I call foundation data collection. So we did EM38, both shallow and deep, digital elevation models, PPH grid testings, soil type maps, the traditional sense on the ground, bedrock surface modelling, and some strategic soils, just going and having a look and learning. So the old EM38, put the skid lid on a guy on a four-wheeler. They seem to be a dying machine in Australia with the new rollover protection rules. So that's side by side now, running its own GPS system and basically looking at it. So in Tassie, we're an old landscape. We've got a lot of salt sitting around. So the blue areas are salt. Basically, you've got that salty little patch there at the top of the image, the blue, that's a swamp. And the red's okay, and then you've got the green. So you can see I've got a very low patch right through the centre, and that's the marsh. The grid testing for PMPH, we did that on 150 metre to 200 metre grids across 240 hectares, having a look, seeing what the pH was like, looking for capital investment. These are what the graphs look like, the outputs of the whole site. So it was interesting to note what we thought was going to correspond to soil type and topography didn't actually correlate at all to the grid testing. Same with phosphate. The purple area you see is sort of what we've got to look at, high rates. So you might notice on, again, your left, there's a strip there that goes through the middle of everything, and there's some green and blues either side. When we did our traditional ground-based testing, we happened to just bloody walk straight down that purple the whole way. And that was about 450 kilos of an analysis blend going on. And it was a pretty high rate, so the whole site was going to be basically a blanket rate. But by adding in those little zones, it was a $42,000 saving in FERT alone for $3,500 worth of testing. So that was enough to buy a second-hand tractor to get the ball rolling. Now, the big thing we did with the drone imagery was these beautiful big orthomosaic photos. So these are ultra-high resolution. To give you an idea of the scale, if you sat a cigarette packet on the ground, we could detect the cigarette packet and tell you where it is within the space of that cigarette packet, but we couldn't read the label on it. But we could tell you it was there on the ground. You go to Google Earth and you zoom in on a pile of rocks, you kind of, is it a tree, is it a tussock, what is it? This stuff you can zoom right in and see exactly what the heck's going on. So you've got this ultra high resolution image, which is great for looking at and is a bit of aggro porn, I hate to say, but very handy. And from this, when you create these photogrammic tools and create these UAV maps, you can create a giant digital surface model. So it's a contour, ultra high resolution. The vertical accuracy is about 5 centimetres, and left and right we're about 2.5 centimetres of where we say we are on the planet. So it's a beautiful tool to start with on a greenfield site. From that, we can then create these plans about this investment. How much money are we going to pour into it? How much is it going to cost to rectify it? Where are our limitations? What are our risk profile? You can all start modelling. Like, computer modelling is a hell of a lot cheaper than going out and getting a dozer and having a crack. You can just sit down for a day, figure it out. So waterlogging modelling, the variable rate maps, huge saving on capital P. Pivot layout, so this is a big one. Ground clearance of pivots. A lot of guys are now pushing into more marginal ground, putting a pivot in and it bridges out. Wheels are down in the valleys, span hits the centre. For very little effort, you could add an extra span in, shorten a span and tweak it. So a lot of that sort of stuff, we do a huge amount of that in Tassie now. In this surface flow analysis, which I'll demonstrate, and we can measure and quantify soil types a lot easier. So drainage of the entire site. So this is a video. I'll click once more to make it play, I think. Try that. So that's the site. We're looking at it from the downhill section, and there's a drain up the middle. And the white that you just see appear, it's not cocaine, that's rainfall. And we're simulating the rain dropping down onto this site. And on the graph on the left, you'll see with time, the water volume keeps increasing. And every iteration, every time we run the calculation, we take a 1 square metre. Where's the water going to go? It goes from this tile, and so on and so on. So the white you see is where the water's going to accumulate with time after a certain volume of rainfall. So basically you can see it running off the hills, the blues and the greens. The colour on the background are contours, red's low. Basically you can see the site's pretty bloody wet. Some idiot wants to put a pivot on it. But from the bottom of that image to the top left where it goes orange is only 30 centimetres of fall. It's a 10 centimetre contour gradient. And when you zoom out, you can see what it looks like when it gets wet. So in Hort, it does have some implications in that with wet ground, orchard sites and various things. Greenfield, getting information like this, you can then start to tweak your row orientation. Farmers love orientating things with power lines, fences and roads. Don't. You can actually dig them by 15 degrees and make a massive difference to what you're doing. So part of this system, you can see the drains drawn in there, they're the blue areas. We've done all the drainage planning, simulated it to see if it'll work, and then we can work out where we've got problems and where things do and don't want to work. But basically, this is a wet site. It's flat, and we want to put a pivot on it. So there it is from above. You can see just a huge amount. You can see existing fence lines, a lot of those lines you see running through it, causing problems. And it takes a bit of doing. Now this is where accuracy comes in. And I'm trying to give you guys a few skills to arm yourself with UAV data when you want to try and engage someone or do some UAV work. Accuracy is everything. So the way we make these photos is we fly the site, we take thousands of photographs, they overlap ever so slightly, so every little blue tile you see there with a stick is the photograph where it's taken, and the black stick's the orientation. Then through trigonometry, we can triangulate it down onto the ground, overlay them, and make a gigantic model. So that's what it looks like with the blue bits taken, all these photographs laid together, and then you create this point cloud. So you take those pictures, triangulate a point with a GPS tag off the photograph, and you create millions and millions of dots, and you triangulate them and you work out with the confidence of where they sit in time and space, and that's your digital surface model. And when you join it together, what look like a heap of dots, you make a skin, it's actually a quarry. So we can use this here, had the dozer in pushing out gravel. He thought he pushed out 2,000 metres. It was, $240 an hour. Put the drone over it, it's actually 3,200 cubic metres. So my price per cube to push it out, I know, with reasonable confidence. Hopefully I'll be able to get an imagery of that little stockpile out the back here in the car park. We can do a calculation off that tomorrow to demonstrate it. Get these measurements there, it's all there, it's great. So when does it matter? Depending on what you want to do with the data. So free-to-air GPS with no ground control points. It's pretty funky stuff. I'm going to make a map out there tomorrow of the car park and you'll see it fish bowls. It distorts, doesn't look right. I call it like a Snapchat of map making. It's sort of there for the laughs. If you add free-to-air GPS and you add ground control points, you can get very close to having a very nice, accurate model. It looks the same, looks a bit weird. There's a couple of lines, some artefacts in the image, but you actually start getting really good, distinguishable maps out of it. There's data to back it up. Basically, you've got to use ground control points. You can't just send a drone up, take photos and make a map. That's what I'm trying to say. So things like Drone Deploy that tell you can, are there to make money off you, not with you. That's the classic example, and it's what's holding this industry back. Guys are trying to make maps, action it, and getting very bad results. So basically, free to air, it just, don't try and make maps out of it, engage a professional. Next speaker's going to talk about it, they do it right. If you want maps, do it right. Well-positioned GCPs, it all matters. So with all that information put together and that accuracy, we basically, ran everything through. We could work out what we're going to do. And in the end, I looked at lots of little pivots, and in the end, no, bugger it, let's just go one of these big ones. And that's what I designed. I did all the drainage design. We worked out building a big man-made drain, where the fences were going to go, water trough lines, the whole lot. Just planned it out off this beautiful data set to begin with. So in the end, I went 942 metre pivot, does 202 degrees, so it's not a full swinger. 1.7 mil pack. So those of you who know much about irrigation, it's a minuscule size irrigation pack. Most pivots are 12, 14, 15 mil. These government schemes sell us a water flow rate. So I get 4.2 megs a day, cuts that back to 1.7, 24 hours, because it's not a full circle, 3 mil. ETO is about 3.5 peak of summer. So these machines are designed to utilise the water 100%, but the area under it not be 100% utilised. But with enough skill and input, you can make it work pretty well. Full VRI on the machine now, so we've got every single sprinkler's individually controlled, and outside 6 bands we went 3 wheels to reduce wheel rutting. It's 20 odd kilometres of wheel ruts less to deal with. Huge drainage works. So I spent nearly $50,000 on drainage before I even had a pivot on site. Total remote control, keeping it simple, the whole lot. So trying to keep down that capex. So that was half the site ready, going down to poppies. Basically landscape changing work, and cash was going out the door at a horrendous rate. Anyone who's done any kind of capex style investment like this in their business knows what it's like, and knows that cash flow pinch that comes, particularly, I've just survived year 3, which was my headache, and I'm just coming out of it literally getting cash flow positive. I understand the headaches. So basically my whole site drainage was my key risk to mitigate in my investment, so we can simulate where we're going to get waterlogging and run it over scenarios with that model we showed. So we can say, you get 12 mil, we're okay. You get 18 mil, gets iffy. 20 mil, 25, 40 mil, yeah, we're in trouble now. And then I had another file called 75 mil stored in the GPS and the auto steer, which is called duck, rhymes with that anyway. And that was if we had flooding, so we'd go cut drains into the paddocks and work out what we were doing. So this is just what we can do. This ultra high res, we can click on a spot and say, draw a drain at 0.1% gradient, 0.5% gradient, whatever you want, and it's a surface drain. And this is the critical thing to think about with drainage. You can either try and move the topsoil with land planing, or you can put in drains following the natural slope of the ground. So we can put it in, it draws it out, ultra high res, put it in an auto steer system and mark it out. So my preferred way to cut surface drains is with low belly scrapers. They're cheap, they're big, they're powerful, and they move a shit ton of dirt. I'll put the auto steer file into the tractor, scratch it out with a grader blade, and then the scraper just comes along, cheap, dirty, simple, picks it up, and then I've got marked out areas where he puts it. Big thing with moving dirt, don't try and fill the low spots because you change the drainage. We shandy it out where there's shallow soils, rocky sections, and put it on the side of banks and stuff, because as soon as you start filling hollows, you start mucking with your drainage plan. And And this is a big mega drain we did. So one thing I did was drain the landscape, 3.5 kilometre drain through my neighbours. So a landscape approach to draining the site was critical. We all benefit. Basically this drain's on 0.1% gradient, dug it out with an excavator in 8 hours. He dug a base and then the scraper picked it up, removed the soil. And what that drain does is, it's a scoop drain, so the pivot can go through it, but it gives me 40 centimetres of fall across a paddock with almost none, and then I can put tile drainage into that. So it allows you to, you think outside the box of where you're moving the water, put your tile drains in, off you go. There it is from above. Just cut a big track down to a salt pan, and then we went out through the bottom of that, out of the landscape. And it's basically freed up a huge area. The other things is positioning, straddling ridges, water holes, objects, not just pivots. I mean, pivots are part of it, but a lot of irrigation systems I see, you've got a lot of constraints around you of things to do, and optimising pipe lengths, pipe distances. With a decent model, you can get all your head pressures, you can do all your hump and hollow falls, airlocks, scrubbing valve points. All that can be designed with a hell of a lot of confidence with a decent surface model to start with. This is the one that I bet a bag of donuts on. The water hole we had, that's about 20 metres deep in the bottom of that in a slot, so we could never really fill it in. It goes to groundwater. The black lines represent where I had the bag of donuts on the bet of where the wheels were going to go. There it is in reality. So we can sit a pivot within about 20 centimetres of where we say we're going to sit it with its wheels. We've actually created an Excel spreadsheet. So we draw the centre of the pivot, and then we take tiles all around it of elevation, and then we draw in the arches of the pivot and basically create a threshold value so that, we basically put it on an Excel spreadsheet, you'll get a red square where it's going to hit. So we can do what we call bridging analysis, change our spans, make all that work, and it's like a 30-minute job for us. And a lot of guys have been very, very happy. Classic example was the guy who was very conservative about it, didn't want to do it, didn't want to spend the money. I talked him into it over a beer. He's got all his pivots put in, and then we had huge bushfires, and his line of defence were 4 pivots that he hadn't fired up that were coming up and over hills. And his first test run was with a bushfire about 8 k's up the road, coming at him pretty damn fast. He was very happy when it didn't bridge out. So, unforeseeable things that can help you out. All these things can be applied. VRI, it's not just pivots to think of with VRI. Hard set, there's a hell of a lot you can do with hard set. Just changing sprinkler nozzles, changing your layout on it. You can go through, change a few nozzle plates out, get wet spots drier. Might seem weird, might seem a lot of mucking about, but it's not that hard if you get that model right. And you literally make a plate chart, someone walks out, changes the plates over, off you go, and that's your hard set squared away. VRI's pretty awesome stuff, particularly on pivots. 1 in 10 have it, but 1 of 10 use it. So 1 in 100 pivots is using it. The software's crap, the interface is crap, the hardware's crap on it. It really needs innovation, and I'm putting it out there now that it's got to be changed. I mean, I spent $100,000 on my system. We nearly ended up in court over it. We're still having meetings trying to get it to work. It's clunky, but when it works, oh geez, it's good. Like, it's brilliant. So you can sort of see there they are, another video, sped up. So you've got weak plants there at my feet. This is just a dead flat spot. One of those white puddles you saw. It just gets a little pulse over it, turns it back off, helps keep the weeds down. If I lose the crop there, it's no good. Rather than feeding the weeds all irrigation season, I just turn the water off. It's magic. So lots of things you can do. NDVI matches up perfectly with what we predicted in the waterlogging, validates what we were doing, and the final execution of the data. So this is the exciting stuff. So when it does that, when you go to a Google Earth map and then you go and put your rings over it and they perfectly match up with where you say the wheels and things are going to be, that's where this geospatial accuracy stuff comes in. So this, the data sandwich I call it, precision ag isn't a silver bullet. It's 5% gain stuff. It's the final part of the business. It's the final run. But to do it right, so many people venture into it and it goes badly and they never touch it again. That's what I was trying to show in that poll. If you can't go to a platform like Google Earth and then upload your imagery of what you planned 2 years before and the image doesn't line up, how can you then go and look back at a kiwi fruit orchard where it's had weak spots and you've got 5 years of data and it just drifts all around the place? It's bloody useless. That's the ultimate result. So kind of why I banged on a bit there about accuracy and stuff. You've got to get this relative accuracy, which is the accuracy of the model, and then absolute accuracy, which is its position in the world. So you can start layering it between tractors, scrapers, field robots, the whole lot. It's really critical. So the data allows you to plan, basically, send people where they need to go for bang for your buck. When you've got something there costing, scrapers are $3.20 an hour, the dozer, $2.20, and then you've got an excavator also running in the same paddock and he's $1.95 an hour, money goes out the door that damn fast. It's not funny. But when you've got a plan, it helps get your confidence going and you just push forward and back yourself to do it because you've thought it through, you've modelled it, you've seen scenarios. It also helps budget where the hell that cash is going to go. So as I said, drainage was my key mitigation risk. This investment was big for me. $1.3 million worth of land, and I was trying to do about a $1.8 million investment. You can imagine how fun the banks were for that. So year one, I go and sow a huge area of poppies. Starts raining, a bit like this, starts raining, gets to 20 mil, 40 mil. By the evening, we're just passing 60 mil. I'm like, yep, it's time for that old duck file. So jumped in the tractor, headed out at 11 o'clock at night, uploaded the auto steer file and started cutting drains through it. And this is the view that got me in the morning. The beauty of it was I knew when to go out and react in the paddock. I knew I could take 15 mil. I knew 25 mil was going to knock a small percentage out. 40 mil and beyond, I was in trouble. 75 mil, I had to go in and really trash the paddock to drain it to try and save anything. And that's what I did. That paddock, if you could go out there in the dark, and I just went out to upper tram line, hit the end of the drain, pressed the auto steer and just cut these mongrel drains there. They're still rattling my teeth when I forget and hit them. You're just looking out the back window and you've got a bare trench and the water is just roaring into it and just follows you out to that main arterial drain. That's a very satisfying feeling. If anyone could do that in the dark, just on gut instinct, no, I will buy you beer for life. And that's it, The water just started coming out of the paddock, we're draining it. I knew how much area was going to be screwed. Out of 80 hectares of poppies, I knew I was going to lose about 28, 29. And the beauty of that is, 36 hours later, that's the same site. It's dry, except for the spots where water was always going to sit. There's about 7 hectares that's just impossible to drain. The water got away quickly. That, on a site with 30 centimetres fall across a kilometre, with hills feeding it, it was brilliant. And the beauty of it then was, I went to the VRI file on the pivot and just turned off all the wet areas, but started watering the bank, because up on the sandy banks and the free draining ground, that's where my bank repayments were. That's where my staff labour bills were. All those repayments were up there on the hill, but if I'd started walking on a big dumb pivot, I would have drowned out all the bottom. So when you have these catastrophic events, you can actually react, and exactly the same as your irrigation systems. On hard sets and stuff, there's nothing stopping you going and blanking all those ones off in that wet area and just trying to drive your repayment section, which is your top of your crop. Too often, we focus on that 5% of torture that you're never going to win with. It might just have a physical limitation or just crap ground. We're so hell-bent on that we let the top part, or the bulk of our crop, go to rack and ruin. And that's something I do see a lot of in precision ag. So, a lot of fruits take your cash. Such a sexy word, precision ag and drones, it just rolls off the tongue. But how do you get that ROI? And I'm hoping I'm showing you that it's a multifaceted process and you've got to think and join dots to make it happen. Plan for the worst case, model it. Drainage is your best bang for your buck. You give me $1, I'll give you back 5. That is the ratio of success we've had now in the last 9 years. Literally have guys spend 10 grand with us and they'll come back with 50, 60 grand back in their pocket. It's only a couple of hectares you've got to pick up, particularly in horticulture, it's even less. For a small investment, done right, massive bang for your buck, and bring those professionals in. So how does it apply in Hort, since I'm at a Hort conference? Basically, frost mapping. That's a big one. So I designed a sensor, no thermal mass, measuring temperature at 60 times a second. So you go up at 2 metres a second, you're basically getting this air temperature every 25 centimetres, every 20 centimetres. And you get up in the drone at 2 o'clock in the morning, take off, go up, find the inversion layer, you've got a real-time readout, GPS logging of all the temperature, and go around, find the inversion. Work out where it is, where its boundary is, find the cold air flow. You can do all that sort of stuff, and then go and readapt or install new frost mitigation devices to get yourself out of that inversion. How high has the tower got to be? All that tech exists, but we just don't get, as a business owner, I can't get traction in that space. Yet then the guys, as we saw in that survey there, polls, everyone who's engaged it, they were consistently, yes, this is good. And that's what I find. You go and do this for guys who are about to put up 12 frost towers in a Cravo house. And so you say, no, that one's got to be 8 metres taller, or, you know, they just go, bugger that, and this one can be 5 metres shorter. You know, lots of little things like that. Drainage, bed, trellis and house orientations. I just keep saying, it doesn't have to match a fence. It doesn't have to match a power line. It's an idiosyncrasy of agriculture. It's just got to be parallel. But sometimes the smallest tweak makes the massivest difference to cold air flow. Again, something you can model. Waterlogging, levelling up sites. We do a lot of stuff for blueberry housing and stuff before they come in. How much cut and fill? What's the cheapest cut and fill for the site they've got? Hyperspectral data. Totally pumped to see that in a UAV format. Just rather than, we've flown the $90,000 UAV cameras, and they're modified for UAV. It's terrifying. It's the most uncomfortable game of electronic horse racing there is. But if it's just got 3 channels in it, you know what 3 you want. It's brilliant. Like, I've used it to find wild radish in poppies just by picking a window where they've got good reflectance and the poppies are stressed after a herbicide hit, and then made zone maps out of it. Like, so much you can do with it. It's just we need research in that space. You know, stop thinking about the bloody tractor. Bugger the drones. You want to know about the sensors under it. Volumetric techniques, blueberries. Going down those, making a 3D model of the blueberry crop, like a sausage sitting on the ground, where it tapers in, the volumetric value gets low, create an investigation area, rather than paying someone to go up and down every row and mark out where they think the weak spots were. You can do all that with a drone in a few hours. We can even do it undercover. We've done it with the land-based rovers. All that sort of stuff comes into it. Solid-state sprinklers, variable rate, the whole lot's there. So I think I've droned on enough. Thank you very much for your patience, and I think we're up to questions.
Well, thank you, Will. I know you did say stop thinking about the tractor, but we do actually have a tractor for you to take home. Perhaps a gift for you to fill in the time on the flight on the way home. No questions on the app, it would seem, and it looks like you exhausted the app earlier on. Good. And no questions on the floor. So, Will, thank you. Being able to combine a passion for flying and computer games and farming into an intriguing business must be a joy for you. And you must be made of tough stuff to farm in that Tasmanian Central Highland area, so he'd fit right in here. Ladies and gentlemen, from Australia, wasn't that netball result great? Ladies and gentlemen, Will Bignell. Yeah, and the cricket wasn't bad either. Now, just a succession of very bright, very clever and intelligent individuals this afternoon who are really doing interesting things. In fact, drones I find fascinating. My wife's cousin is an engineer on a major road project just north of Auckland. He doesn't have to tell me what he does, he can just show me with the incredible drone footage that is available to all. And when I think of how cumbersome cameras used to be, it is astonishing. Well, let's continue with on-farm technology adoption and bring in Tim Cupfield. He has a wide range of experience in a wide range of areas. GPS-it specialises in agricultural mapping services and mapping-based software. From GPS-it, please welcome Tim Cupfield.